This is part 3 of a video series I made about hi-fi audio on VHS tape. To modify a VHS so you can record audio from a very high quality comparable to CD. This unit I discuss in part 1, and if you want to know more technical details about hi-fi in general, look at part 1 of this video. I had an extra spare unit in stock, so I use this one now to also modify it to high quality audio recording, and for that I designed and built an external interface, an external converter. I received so many questions after part 1, so if it's possible to build a thing like this, a universal converter that you can use for VHS, beta, U-matic. I didn't make a circuit diagram of the whole unit, so that's not available, maybe in the future, but I have my notes, so if you stay on, watch this video, later on I will explain the schematics and go more in depth about the electronics. Okay, let's start with the overall diagram. Over here you see the audio input. It's going through a low pass filter. It's amplified. There's a small pre-emphasis, 15 microseconds, 4 dB per octave, an HF rejection, and from here it's going through the VCO. And that's a story for itself. An output amplifier and to the video heads. Also channel 2 is injected here. The best way to use a VCO is to let it free running. And because I wanted a deviation of almost 250 kilocycles, it makes the thing very simple, but in the long term there's a possibility that the VCO is drifting away after a few months. So I decided to have it stabilized, and that stabilization is from a small part of the output RF here is going to a divider, and it's counted down to 100 kilocycles. That 100 kilocycles is compared in this competitor with 100 kilocycles that's arriving from a crystal oscillator. So you get 100 kilohertz, and the output is a DC, and it's going through a low pass filter and back to the VCO. So drift in the long term is not possible in this case. But you have to be very careful. If you use a phase loop like this, the output of the competitor must be filtered very, very carefully, because every small amount of correction will be noticeable in the audio. So this line must be very, very quiet. So I used a low pass filter that's almost 20 seconds. This is my VCO, and it's a simple transistor in a standard configuration. Only special thing are those two VARICAP diodes. They are BB112, but you can use any VARICAP, of course, as long as it's in this case I think something about 300 picofarads max. So that's quite large for a VARICAP. But anyway, I used those two to adjust the frequency of the VCO. One line is coming from the stabilization, so in the long term this will stay exactly on 1.5 megahertz, and also here the audio modulation. The output is buffered here by two transistors and will produce an RF signal of about 10 volts peak. So I produced a 1.5 and 2.5 megahertz subcarrier, FM modulated with audio, and here I combined the both channels in here, the 1.5 megahertz and the 2.5 megahertz. The 1.5 megahertz has an extra coil to suppress the second harmonic. They're combined in a potentiometer, so you can very fine adjust the balance between the two carriers. And in here the total volume of the carriers that's going to this integrated circuit in LM7171, and that's going out to the video drums, so it's directly going to the rotary transformer, and can be adjusted between 7 or 15 volts. And that's very, very important, because with this potentiometer you also adjust the current to the video head, and that depends on what type of tape you are using. Also, the crystal oscillator is used to drive this deviation and this deviation, and it's producing a horizontal sync and a vertical sync. combined here and buffered to the output, because I think 90% of all VCRs like a video signal on their input, otherwise the servo systems of the VCR are not synchronized. You really need it. Also, the audio itself needs some electronics. Let's have a look. This is the audio input, the manual volume control, so you have exactly in hand the deviation, in my case on 200 kilocycles, a low pass filter, some buffering, and very important, the pre-emphasis, an RF suppression, because here you have your oscillator, the two varicap diodes from the oscillator, and here you have your audio frequency. So to get it separated, you need a coil there, and that's it. This is what it looks like if you put an audio sweep to the input. You're free to choose your own frequencies. 1.5, 2.5 is a little bit high. If you can choose a lower frequency, starting with, for instance, 700 kilocycles, because it makes a greater difference, a greater distance to eventually drop out. Drop out is not noticeable usually by hi-fi, but you can compensate for it, but not the way a VCR does. You need a special dropout detection in the audio section, but that's a complete other story. A very small amount of RF is going through the playback amplifier that's here. Normally it's signals coming from the video heads, of course, and going through a filter to the demodulator, the de-emphasis, audio amplifier, an output amplifier, and it's outputted on line level, pro line level. Also, there's a few meter, because you have to manually adjust the volume to get the right value for the VCO, the deviation from the VCO. I used the playback amplifier from the VCR itself. So from the video drum, from the video heads, there is a pre-amplifier available in the machine. And you have to be very careful to use that one, because most of the VCRs are also having a dropout detection in the same integrated circuit. This is the RF coming from the VCR, from the preamplifier of the VCR. In an amplifier here, it's greatly amplified, about 10 volts peak, because in this filter here, this filter, the two channels will be separated and cleaned, because there's a lot of noise on tape, of course, and I found it necessary to clean up the two carriers, and I built a filter tuned to 2.5 and a filter tuned to 1.5, but the problem was that this whole filter is also losing 40 dB, so you need an amplifier in front of it. Demodulation. I selected an integrated circuit because I didn't have the time to develop a demodulator of very high quality. And you're free to do that, of course. I used an integrated circuit from a television set called here in Europe the TBA 120. You'll see here the RF coming from that separation filter, one to one TBA and one to the other TBA. And in here you can look on internet to find the details of that integrated circuit. But it's very, very simple. Only thing you have to do is to wind a coil yourself, because there are now standard coils for 1.5 megahertz and 2.5 megahertz. So I made something myself, but I'm afraid you have to develop something by yourself. Also in this integrated circuit is the de-emphasis. From the RF going into the TBA, here is the audio output. It's superposed on 6-volt DC, but it's about 100 millivolts on audio. And here you find a capacitor, and that capacitor is very important because that is your de-emphasis, and it has to be in line with the pre-emphasis of your record amplifier. And after the demodulation, put that audio in a low-pass filter. And as I explained earlier, there is no Dolby and there is no compression. But if you want to have the best signal-to-noise ratio, you can select DBX, Dolby, or whatever you want, and insert it here in on this place here. From this low-pass filter, it's going to the output amplifier, ordinary integrated circuit, and is buffered by 2 transistors. Also, this low-pass filter is feeding little thing here, and that drives your VU meter. Very straightforward. It's a FET BF245. Another amplifier with a transistor. Also the playback is mounted on a circuit board, of course, and this is the board. Very simple amplifier, RF, 2 demodulators, of course, 2.5 and 1.5 megahertz, with their coil, amplification, output stages, and this part is to adjust the VU meters. Finally, a power supply. I didn't use a digital switch mode power supply because you're dealing with very small audio signals, and you don't want noisy power supplies. So this is a linear power supply, very simple. A transformer, diodes, stabilization, and that's it. That's all there is to it. On every circuit there is a little coil and capacitor to earth to clean up anything that might be on the power supply, but I couldn't find anything. Okay, that was it. My project, universal interface audio for VCRs. Thank you for watching. See you in the next video. Bye bye.